Warm welcome to this session of Wind Power Project Management Podcast. My name is Milan, and today I have a guest with me. It's Leiting Zhang. Very warm welcome.
Thank you.
On campus.
Thank you.
So today's topic will be about battery technology. Could you maybe give us a brief introduction? What is your background? What are you working at?
Sure.
Yeah?
Yes. So I'm an assistant professor at the Department of Chemistry, Armstrong Laboratory, Uppsala University. And my main research topic is about batteries, as you mentioned. So we work on different battery chemistries. So not only lithium-ion battery, that is the conventional technology, but also next generation. So when we are talking about sustainable battery chemistries in the future. And I'm also involved in methodology development to study batteries.
So when we look at the electrification in general, renewable energies come with fluctuation. So battery storage is always a topic. Electricity in the grid is usually produced and consumed at the same time. So there is a need, but could you probably give us a deeper look into the need and why do we need many batteries?
Yes. So first of all, as you mentioned, the sustainable energy such as solar or wind, they have this intermittent characters. That means they are not always there, and then that's the reason we want to store the energy in the form of chemical energy so that we can reuse them whenever we need. And also one of the advantages of batteries is it has a quite high efficiency for this conversion. So you can store most of the energy from electricity into batteries and then from the chemical energy back to the electricity. That's why we are now working with batteries for energy storage. If we talk about rechargeable batteries, actually the very first rechargeable batteries are the lead acid battery. They're still being widely used actually. And then from there we have nickel cadmium and nickel metal hydride, and now recently the lithium-ion battery technologies. So they are there for different needs. Right now most of the market has been taken by the lithium-ion technology because of its high energy and also high power compared to the previous water-based batteries. But the main challenge with lithium battery is lithium has a quite relatively constrained share in the Earth's crust. The abundance is relatively low. Then if we're talking about other type of grid energy storage, you cannot only rely on lithium since it's only limited. And that's why we are looking at next generation battery chemistries that's supposed to be much more abundant and cheaper and also more sustainable for grid energy storage.
Right, and I think you already covered it a bit. What is the outlook for battery technologies comparing to now and maybe also comparing to the past?
Yes, I mean, for example, if we look at just the electric vehicle, the demand has kind of exponentially increased. And then most of the batteries, the inside, they are actually lithium-ion batteries. Because, as I said, lithium-ion battery compared to all other type of battery has the highest energy density. And then for applications like this really energy demanding application like cell phones or EVs, lithium-ion is the only or one of the best battery chemistry. That's why we are really have a very high demand for lithium-ion technology right now.
And how do you see the development of large storage plants? For us, for wind power students, it will be more maybe in this direction that we need to store the energy we produce when the wind is there?
Yes. Yeah, I did some homework. So there's, for example, lithium-ion battery used for wind turbine, but also maybe, for example, lead-acid batteries. That's a bit old type, but still it's very cheap. And then cost is definitely one of the main issues when you need to think about for batteries for wind power, for storage, for example. Lithium-ion has the highest energy, but then it's also relatively more expensive than lead-acid. While for lead-acid is much cheaper and also it's much safer. So actually it depends. We have a lot of parameters for batteries like safety, price, sustainability, energy. So when you really look for some product or application, you will need to see what's the best chemistry. There's no, let's say, magic battery that can solve everything. So we will need to see what we want and then see what kind of battery can match with the demand.
Okay, when we're looking at wind power storage, it would be not like storing it for weeks or even days. It's more like storing it for short term. So which technology would you say would be most suitable for these plants?
Still, the lithium-ion battery technology is the most studied and developed. It has been ever since Sony commercialized it in 1991. It has been more than 30 years, and it has the best or promise and also power and capabilities for energy storage. So that explains why lithium-ion technology is the one go-to battery for wind storage. And also, one advantage of lithium compared to the previous nickel, cadmium, nickel metal hydride is does not have any memory effect. That's a effect that will eventually lead to degradation of battery chemistries if you don't fully discharge it. While for lithium, we don't have any problem with that. That means basically you can, whenever you want to charge it, you can charge it. Whenever you want to discharge it, you can discharge it. So it's very flexible, so easier to cope with the demand and requirement for wind turbine, for example.
And you were saying about totally discharging and maybe overcharging it. In general, what would you say is the best for a battery?
Well, yes, in a sense, as I said, batteries, they don't want to be really over-discharged or overcharged. That's why, for example, for cell phones, typically there's already some circuit integrated into a cell phone, so it already constrains or optimizes the charging, the protocol for charging. So my advice is you can charge whenever you want. You don't need to wait until it's below 10 or when it turns off automatically. It's not the best, and you don't have to keep it 100%. I know someone really want to keep it 100% anyway, but I would say 80%. This is enough for most of the daily applications.
All right. You covered many different types of battery technologies. Could you briefly go a little bit more into detail how it works from a technical side, so the chemistry behind it?
Yes.
Probably?
So if we're talking about lithium-ion battery, it has a positive electrode and negative electrode, and in between there's an organic-based electrolyte. So for the positive electrode, typically we use a lithium cobalt oxide. So it's a layered material, and then lithium stores between the layers. And then on the negative electrode is typically graphite, so it's carbon, and it's also layered. So when you charge and discharge the phone, basically lithium ion just move from one side to the other. And then during charge, the lithium ion from the lithium cobalt oxide to the electrolyte, and then goes to the graphite. And during the discharge, then lithium ions move backwards from the graphite to the electrolyte and then to the positive electrode. And then the electron move in the same direction in the outer circuit. That's where you convert chemical energy into the electricity. So this is we call it intercalations or insertion chemistry. So lithium ions just move from one side to the other. So rock chair type of chemical reactivity. So that's the most common mechanism to power batteries, not only for lithium, or they can be also applied to sodium, for example. Then you just change the charge carrier from lithium to sodium, which is a bit bulkier or slightly bigger. But then sodium also ions move from one electrode to the other, vice versa. So this is the typical way for storing electricity and converting that into chemical energy.
Okay, you were already mentioning the sodium, so
yes.
The principle is the same, but you say the battery will be a little bit bigger in general?
Yeah, as I said, the main issue with sodium is slightly bigger, the ionic radius, but also it's heavier. So in a way, if you use the same type of material, then the specific energy will be slightly lower. And also, sodium has a slightly higher electrode reduction potential, so which means its total energy will be also penalized by this higher electrode potential or reduced electrode potential. So overall speaking, you're having 300 millivolt of lower voltage when you have sodium compared to lithium. So if you want to have something with higher energy, you prefer the lithium than the sodium because sodium has a bit lower potential. And also sodium is heavier, that means per unit mass, it's also less energy. That's why sodium-ion battery is more preferred for applications where you do not really require high energy.
Mm-hmm.
That's why there are, for example, applications of sodium batteries can be for electric bus, but not for personal electric vehicles, because for personal private electric vehicles, you really want to have high power, but bus, it's much bigger size, so you're not so picky about the energy.
Mm-hmm.
But for cell phones, you would definitely want something with higher energy, then you should go for lithium rather than sodium.
But that sounds also like sodium could be a solution for large storage plants, which are stationary, so we don't have to carry them around anyway.
Exactly, that's the point, because in areas where the size or the volume is not really a constraint, then you can build a bit larger battery, but then it's fine. But then that can be much cheaper, for example.
Cheaper and also easier to manufacture, probably.
Much cheaper in terms of raw materials
Yeah.
for sodium. For example, the abundance of sodium in the Earth's crust is roughly 5,000 times higher than that of lithium, so it's
Yeah.
much easier to get sodium.
Oh, right. Okay, so would you say that there are more trends, or is sodium like one of the big trends? And is it something you see in the future?
I mean, sodium batteries has been in the market actually. We have actually CATL and Altris. I mean, Altris is a spin-off company from my Department of Chemistry, Armstrong Laboratory, and they are actually producing positive electrode materials for sodium batteries. So sodium-ion battery is in the market and it's taking part of the entire market share. But there are also other type of battery chemistries for future. For example, I'm not sure if you've heard of solid-state battery. This type
Yeah.
of battery, the idea is to replace the flammable organic electrolyte from a liquid state to a solid state, either polymer-based solid electrolyte or a ceramic or like metal oxide-based ceramic solid electrolyte. So the advantage of the solid-state battery is supposed to be much safer since it's non-flammable, and also supposedly to have also a quite high energy. So, but has been shown with good cases in the lab case, but from lab to commercialization that also takes some time.
Yeah.
So
I guess it's also something about costs. So
yes,
it will be
definitely in the lab when you don't really care about the cost, you can make very high quality, high performance solid state batteries. But then when you go to the market, eventually it's the customer who will pay for the battery. So do they want to have something slightly safer but then more expensive, or put it another way, you will need to mass produce the solid electrolyte. That is something not yet mature.
okay.
There's a term called TRL, so technical readiness level. So when it's 1 or 2, that means it's really in the lab. When it's 8 or 7, 8 or 9, that means it's more towards commercialization. I would say the solid state battery is still somewhere 4 or 5, something in the middle. It's definitely not yet commercially widely available.
Okay.
One of our ongoing trend is to try to, for example, reduce the price, but also increase the stability of the solid electrolyte. As I said, it's quite reactive towards water or sometimes air. That's why we cannot really produce it in an open environment. We need to control the environment, the gas, and then the moisture content. So it's really you need to be very careful when you produce these materials. If we can make more stable solid electrolyte while we still keep the performance, then we can lower the price. This can be done in the near future.
All right. And we as students are currently like preparing ourselves to enter the energy sector.
Mhm.
And is there probably something you would have like a personal advice for us?
Yes, I would say energy is definitely one of the top topics in the 21st century, about energy conversion, energy storage, energy collection, or even energy, various aspects of energy related, or even security now, national security or whatever related to energies. So you can do a lot of things related to energy, especially for the wind, for example, wind energy. I know that Sweden has a lot of this potential for offshore wind turbines and also energy storage related to wind. And I think applying your expertise in different energy related sectors will benefit not only you, your family, yourself, but also this society a lot. So and also one of the trend is now is we are having more and more ongoing interdisciplinary collaboration and research. So in the future, you may also have a chance to work with chemists, material scientists, or even politician or economist for different projects.
Yeah, to combine all the aspects that are needed for
Exactly.
the energy transition.
Yes.
All right. Then, very, very much thank you.
Thank you for having me.
This is it for today's podcast.